Today I'm going to talk very briefly about Codan. One time Codan were completely dominant, particularly in the transceiver market. Over the years, transceivers have fallen out of fashion, mainly because they were a lot more expensive than BUCs. Typical cost, this goes back to about 2000, so I may not be accurate. An 8-watt transceiver, maybe $12,000, $14,000. Then the BUCs came along, an 8-watt BUC, which would really replace the transceiver, would cost not even half that, so perhaps $4,000 or $5,000. This was one of the main reasons why they stopped being so popular. The transceiver concept is fairly simple. The idea was to make a rugged piece of equipment that could sit out on the antenna itself and use a fairly simple modem, typically 70 megahertz or 140 megahertz modems. And they are cheaper than the L-band modems that came along later, but not by a great deal. Now I have two of these standing back to back. They're identical, but this means I don't have to shift the camera from side to side. Here of course we have the control. It mainly controls the interface to the computer because these need to be controlled by a computer or by a handheld device. This is the connection that will go directly to the serial port on a computer. This is the power supply. The power is supplied via a separate Codan box. We have those in stock. I'll show those in another video when I put together a complete transceiver system. And now we have the IF interface. On one side we get the input from the modem, goes out to the antenna, it comes back, and then it returns to the modem on this side. So modem input, modem output. Over here we have the RF side, the radio frequency. In this case we're going up to KU band. So the 70 megahertz or the IF signal is converted. It's going to go out by RF to the antenna. The return from the antenna will come back on the other side. It gets converted back down, and of course it comes out here and goes back to the modem again. So that's the full cycle. Over here we have the controller for the SSPA. The SSPAs that work well with these are 4 watt, 8 watt, 16 watts. This converter supplies all of the power necessary for the SSPA to operate. And also through the M&C connection, it supplies the necessary information as to output power and so on that is required on that SSPA. Codan did make one more powerful SSPA that would work with these transceivers. It was a 40 watt, but that required supplementary power. I believe it probably had an extra AC power connector to supply the 40 watt. The power supplied to the smaller SSPAs is 48 volt, and it will come from here via a special dedicated cable to the SSPA. One of the most annoying things about Codan, now I'm going back 15 years now, we never seemed to be able to get cables quickly and easily. Everything seemed to come from Australia. So if you wanted a $100 cable, it was another $300 in freight or something like that. That may have been one of the reasons they decided to get out of the business. Some people are still in the transceiver business, not many, but people like Advantech and I think Agilis, they both make complete transceiver packages. So there is still some demand for it. And if you have a really cheap 70 megahertz modem, and you don't want to upgrade to an L-band modem, a transceiver is still a decent option, especially if you can pick them up on the used market very, very inexpensively, and they are still around. We like to keep some of this equipment in stock because from time to time we get cries for help. I desperately need a converter. Can you please get me one in a hurry? In a lot of cases we have it. Anyway, that's it. That's today's look at a Codan transceiver, or part of a transceiver. This is the converter.